Yes, guys, warm welcome again to you all. And today we will be starting with yet again a new topic, and that topic is something called as finite state machine. It's called as FSM, a finite state machine. Today we will be learning on this, and I'll be explaining that. Going before to a finite state machine, which I've been explaining in a previous class, and yet again I'm just going to explain about these few terminologies where you all know about these terminologies, and that is let remember or recall the things called few terminologies like symbol, alphabet, string, and language. Okay, let me tell you the things in the way. What do you mean by symbols? These are characters. For example, A, B, C are a symbol. 0, 1, 2 are a symbol. In other way, E, U, it's a symbol. These are the symbols where we come across, and this is called as a set of symbols where we use in a finite automata. And next thing is called as an alphabet. Alphabets and symbols both mean a same. Symbol alphabets is always been represented as sigma, where it's a set of symbols. Okay, alphabets are a set of symbols where we come across with. For example, we write as an alpha sigma of A comma B, sigma of A comma A. This is a thing. It's called alphabet. Next, let me come with a string. What do you mean a string? A set of alphabets forms a string. A set of alphabets forms a string. It can be in any other format. For example, if I write a letter AA, it's called a string. A set of symbols together one forms, it's called as a string. And AA is string, 001 is string, is a string, AEU is a string, and this is a string. And next comes a language. What do you mean by a language? A language is a collections of a string, what we call as a language. Language, for example, let me take an L1, where L1, here I give a condition. Set of all string starting with AA. For this, the examples are AA is a basic one, B, AA, BB. These are examples of a language. This is language 1 or one language. What I say, I can take L2. Same old thing. Set of all string starting with B. So for this, the examples are BBB and BA, and many more things I can continue. Clear, guys? These are the two terminologies where we have to recall before starting with a new topic called a finite state machine. Guys, I'll just go with giving an examples of a finite state machine. Then I give a definition and a detailed explanation about finite state machine. First and foremost, like which example let me take with the finite state machine? I got few things as an example, and that thing is let me design a machine. Machine meant to say a diagram. Okay. From now on, keep one thing in mind. Whenever I say machine, don't feel like it's a hardware machine. Either lathe machine or system engine or 2-stroke machine, 3-stroke machine, sorry, 4-stroke machine. That's not a machine. In our terminology for a computer science, whenever I say called a machine, it's a diagram. It's a diagram. For example, a data flow diagram. Similar kind of a machine will be designing here. Clear? Okay. Now I am designing a machine for a sheep talk recognizer. I'm designing a machine for a sheep talk recognizer. I think you guys know what you mean sheep. Sheep meant to say exactly. Kuri. Clear? I am designing a machine. For example, I'm designing. Okay, assume like I have a door. If a sheep comes and it speaks, the door has to open. Now the question is, the sheep comes and it speaks, the door will be open. Now you guys have to tell me, what does a sheep speak? Will it speak, "Hi, how are you? Open the door"? Nothing. It speak only few things as it says BAA, bar. Clear? This is an end. Clear? Okay. Or in a Josalito, or it might be in a proper Jos, it might say B followed with A's. end of it, or B, assume that this, or it continues. Don't you guys feel whenever a sheep speaks, it speaks only in this manner? Ba, ba, and ba. For example, a lazy guy like someone over here, they will say only ba. Why to waste my energy? And a guy like someone who says with more energy, ba. Clear? This is a good example of it. So let me design a machine for a sheepdog recognizer. Before designing a machine, I want you all to remember few symbols. Few symbols, not that symbol, few diagrammatic symbols where we are to design the thing. For example, the first one, there's something called as a circle. There's something called as a circle. Circle represent state. S-T-A-T-E. Circle represent a state. Let me go with the second one. Second one, there is something called an arrow mark with a symbol on it. Arrow mark with a symbol. Symbol means, as I have been said to you, there can be A to Z or 0, 1, 2, 3 or I, U or anything. One symbol or a type. Only one symbol, and this is called as transition. In other words, transition is or you can say as a flow. Clear? Either you can say as a transition or you guys can say as a flow. And the next one, I represent the third one as, there's something called as a double circle. There's something called as a double circle. What do you mean by a double circle? Double circle means, when I represent a single circle, this says a state. When I represent double circle, it says a final state. Whenever I represent double circle, it says a final state. Single circle, only state. Double circle, final state. And let me go with the last. Let me go there. There is something called a circle where a circle will be having an arrow mark to it. There will be something called a circle where the circle will be pointing an arrow mark to it. This says as start state. Is that clear? Is that clear, guys? Okay. Now let me repeat that. These are the symbols where we'll be using these symbols and we'll be designing a machine. We'll be using this other symbol and we'll be designing a machine. For example, let me take a single circle. Single circle represent one state. Arrow mark with one symbol represent a transition or a flow. Double circle represent a final state, and a circle with the arrow mark represent starting state. Is that clear? Okay, now I've been done now with the diagram. I know how to design a thing. So now I have to start designing a diagram. How to design a diagram? To design a diagram, first we have to think one thing in mind, which is a bare minimal string where a machine can be designed. Which is a bare minimal string where a machine can be designed. For a bare minimal string, how does, for example, for my example, how does a sheep speak? First one, if the sheep is a Sumeri or another word, it says only B-A-A-N. Clear? It's only ba, a step. If the sheep is more energetic, it speaks in a different way. But a minimum of sheep speak as B followed with 2 A's. Clear? Okay, now let me design the things. So how to design a diagram? First I write a state. And I name the state. How to name a state? Simple. I named as, there will be many circles like this. I just not get confused on a circle. So I name the state as Q0. Next state as Q1, Q3, Q4, Q5 till the end of a machine. Clear? Okay. Now I write a circle and name a state as Q0. Okay. And this is a starting of a state. Starting till bar part. So starting of a state, how can I do it? If you remember the fourth point, if I represent an arrow mark, this says starting of a state. Clear? Okay, now let me come up with the things. First letter or first symbol my machine has to accept. Whenever I say about a machine will accept a bit by bit. For example, my default things are 1, 2, 3, 4. 4 bits are there. Okay, now I'll go to a machine and I get a first symbol as B. I'll go to a machine, I get a first symbol as B. If I get B, I'll go to my next state. So I name this as Q1. Clear guys? Starting off string. If I get B, go to Q1. And next, what should be next? Next bit. Next bit is A. If I get A, go to Q2. Correct? The next bit is one more A. If I get A, go to Q3. Clear? My last bit is exclamatory. If I get a not, go to a state called a final state. How do I represent a final state? I represent a final state as double circle. Is that clear guys? This is what we call it as a machine. Clear? This is what I call it as a machine. So I repeat again. First and foremost, I will design a machine for a bare minimal string. And the minimum string given by a question. This is a question. Question says a sheet recognizer. For this thing, I will design for a bare minimal string BAA exclamatory. Now I iterate. I trace the given program. Okay. First time in a starting state, I get a symbol B. Yes, I'm going to the next state. Next I get a symbol A. Yes, I'm going to the next state. Next I get a symbol A. Again I'm going to the next state. Again I'll get a symbol exclamatory. I'm going to a final state. Now my string is over and I'm into a final state. Clear guys? My string is over. I'm into a final state. That meant to say the given string holds good. Is that clear? Now the given string holds good. Okay, now let me go with, okay, I will trace with my first string. Let me trace the second string. Okay. I'm in a state called Q0. Okay, I'm in a state called Q0. Now, first bit is B comes. Okay, now B comes. I'm going to Q1. Now again B comes. I'm going to again A comes. I'm going to Q2. Then again A comes. Now I'm going to Q3. Clear? Now one more A comes. Where I'm going from after Q3 to A? I'm not yet defined anything. I'm not yet defined anything. If you observe the things properly, if you observe this thing properly, don't you feel the first three bits are the same? BAA, BAA and BAA. If you observe it, this part is getting iterated. Andre, follow. This thing is getting iterated. So, for this, can I use an iteration in a state called Q3? Can I do an iteration in a state called Q3? I write like this and I call it as a thing. I write like that, I call it as, for example, let me trace B, A, and exclamatory. Okay. B, A, exclamatory. The string is true. By the end of the string, I have to be in a final state. And hence, this is a final state machine. Is that clear, guys? And this is a finite state machine. Okay. For this thing, we have to write few more things. For this is a final state machine. Okay. For this, there is a new thing called a transition table. There's something called as a transition table. What do you mean by a transition table? It is represented like this. It is represented like this. For example, here I write the column name I give as a symbol. What are the symbols used to design this? There is a symbol called A and there is a symbol called B. What are symbol? Symbol called A and symbol called B. If you remember things, there is one more symbol. Which is that symbol? The last one. Exclamation. Clear? There are three symbols used. Clear? Okay. Here I start listing a state. How many states are there in my machine? There are 5 states. I write as Q0, Q1, Q2, Q3 and Q4. Clear? Q0, Q1, Q2, Q3 and Q4. Okay, now I'm in a state called Q0. I'm in a state called Q0. If I use a symbol A, where am I going? I'm not going anywhere. So I use something called as null. Bodhila, I don't know anywhere. I will stop. Okay. I'm in a state called Q0. I get a symbol B. I'm in a state called Q0. I get a symbol B. Where am I going? I'm going to Q1. So I write here as Q1. I'm in a state called Q0. If I get a symbol null, exclamatory, where will I go? I write as null. Clear, guys? Yes, same. I'm in a state called Q1. A comes, I'm going to Q2. B comes nowhere. Epsilon null comes nowhere. Nowhere means saying null. Okay. I'm in a state called Q2. A comes, I'm going to Q3. B comes. Q2, B comes nowhere. I'm in a state called Q3. A comes. Where am I going? I'm in a state called Q3. A comes. Where am I going? Q3 again. I'm writing this as Q3. If B comes nowhere, I write it as null. And if exclamatory comes, not symbol comes, I'm going to a state called Q4. I'm sorry. I'm going to a state called Q4. Okay, now I'm in a Q4. I'm in a state called a Q4. If A comes nowhere, B comes nowhere, null comes nowhere. So I write this as null, null, and null. Is that clear, guys? This is a new terminology, and this terminology we name it as transition table. Is that clear? Is this clear? Okay. Now I'll tell you, I'll repeat this again and I will be explaining it. And the thing is, like, now we are into a new topic and we are starting off of machines, and that is there's something called as a finite state machine. Okay. When I would call it finite state machine, I haven't explained or I haven't defined the things properly. I've been taking an example and I make sure for you guys to warm up how to write a finite state machine. For this, I will take an example of a sheep talker or sheep talk recognized machine. For example, a sheep comes, stands in front of my door, and it speaks. If the string is valid, it has to open. If the string is invalid, door will never open. For example, for the given sheep, I will start listing the strings. For a given sheep, I will start listing the string. How can a sheep speak? So I say BAA, bar, then a longer one, or a medium one, and a shorter one. It can be anything. First and foremost, I have to list the minimal thing. It starts with BAA, bar. It has to speak that. Clear? Then I start writing how many true strings is there. For the given thing, I start writing a machine. First and foremost, first state. It is always a default, and the arrow mark represents a starting of a state. And I name a state as Q0, Q1, Q2, and a Q3, Q4, Q5 till and end. This is called a naming of a state. This is called a transition, and this is a final state. Okay. Now I'm in a state called Q0. What is the first bit and the first symbol, first alphabet I encounter? My first alphabet which I encountered was B. I'm in a state called Q0. B comes, I'm going to next. Next, A. I'm going to Q2. Next, A. Correct. And last is exclamatory. Done. And this is the last of this thing. When I encounter this is the last, I make the last state as a final state. Clear? Okay, now this is true for my first basic thing. If I speak a longer one, a bar kind of thing, what I do? B, A, final string. But A iterates n number of times. So what I do? I write A over here n number of times. Clear? And whenever this symbol encounter, I'm going to a final string. Is that clear, guys? This is what about a machine. And next thing what we have to learn is something called as a transition table. Next thing what we have to learn something called a transition table. What do you mean by transition table? I will be listing something with respect to a tabular format. I will be listing something with a tabular format, and I name as a naming convention as I name as a column name as a list of symbols. I name a column name as a list of symbols. Here for the given machine, which are the symbol used? B, A, A used, excuse me, three symbols used. So I will written as A, B, and estimate. Clear? And next, how many states are there? I write with respect to a row wise. How many states are there? I write with respect to a row wise. For example, here Q0, Q1, Q2, Q3, and Q4. Q0, Q1, Q2, Q3, and Q4. Done. This is what exactly a tabular format, a template means. Okay, I will make this as a template, and now I'll be writing the details inside a template for how to do it. I'll go to a state called Q0. Q0 only, if I get all these three symbols, where will I go? Or where will I jump? Or where will the flow happens? I'm in a state called Q0. If A comes, I'm not going anywhere. Whenever I say not going anywhere, I use symbol called null. Yeah. Q0, not going anywhere, null. Q0 B, yes, I'm going to Q1. Q0 epsilon, not going anywhere, null. So I write each and everything in a detail. And this word is called as a transition table. Is that clear, guys? This word is called as a transition table. Okay, now let me explain how exactly this works in a given machine. For example, okay. Okay, for example, now how exactly this machine works? I will send out W. What do you mean by a W? W stands as a word or a strings. I will send a W to my finite machine. FM. Okay, I write FINAT, finite machine. Okay. If I get a true string, it gives me yes and as accepted. Okay. If the string is true, I get a message as yes, the machine is accepted. Yes, it can open a door. If the given string is false, false means to say no. What will the message get? Not accepted. Is that clear? Either I will get an accepted or I will get a not accepted whenever a word is being sent to a machine. Whenever a word is sent to a machine, I will get like this. Okay, now, sir, how exactly machine look like? How exactly a machine look like? This is how a machine will be. Okay, this is how the machine will be. And this is I'm sorry. Okay. There will be something called as a finite control. For the given finite control, there will be a read-write head for a finite memory. Finite memory. There will be something called as, okay, what will be inside this machine? What will be inside this machine? There's something called as tape. There's something called as a tape. There will be something called as a finite control. There will be something called a memory. These three parts will be there inside a finite machine. So how does it work? A simple way. As I said, there is something called a finite machine. Finite machine will be having a read-write head. Finite machine will be having a read-write head to a tape. So what do you mean by tape? Tape means say it's a normal one, a magnetic tape or any sort of a digital tape. Let me come up with a magnetic tape. I hope you guys have been seen a tape recorder. For a given tape recorder, there was a cassette. I don't know how many have been seen the cassette. If you remember things like in your house, the old cassette will be there. You can speak with your parents, and I think they will be kept at least one cassette in your house. Please have a look over it. For the tape, there is something called a brown strip. Okay, the tape recorder has a cassette. That cassette has a brown strip. What has been written? Each and every bit of the strip, it's a magnetic tape. Each and every tape, each and everything, a bit of music will be inserted over. So when the tape rotates, the music hums. Is that clear? This is how a tape works. Even the same way, a digital tape, magnetic tape, all the tapes will be in the same way. For example, let me explain the same example how exactly it works. Clear? Another thing, first and the foremost thing how exactly it works. Okay, now I load one string to a tape. For example, BAA and exclamatory, I load as BAA and then symbol called not. Clear? Okay. How exactly it work? Okay. And here it will be the memory will be having a thing like finite control will be having a memory, and that memory I think is a true or a false string. Okay. First it goes to B, it saves BOE. Then it move always it move a right shift. It moves A, it goes here. Then it goes one more A, saves here. It gets not, it saves here, and it goes there. This says an end of a string. I don't have a string over here. Clear? These are all the values I'll be getting BAA and with the not symbol, and now it encounters. I got a not symbol. Am I in a final state? If I'm in a final state, my finite control will navigate me saying like, yes, accepted. Clear guys? If a machine BAA and a not, it will be saved in a memory, and my finite control I will be having in which state I am in. It says the Q0, Q1, Q2, Q3, Q4. If I am in a state called a Q4, end of a string, my finite control will say string has been ended and I am in a final state. This machine is true and it's been accepted. Clear? Okay, now let me give one more example. Assume that B and with entry exclamation, let it enter the same way. Okay, now first it loads B, done, loaded, goes to right, it loads A, loaded, next it loads B, loaded, it loads exclamatory, yes, loaded, it comes across a null, I'm the end of a string, yes. Now my final control will go and chuck it out. B, A, B. Nowhere. It has been stuck in which machine? Which state? It has been stuck in Q2 state. So string has been over. My machine is in Q2 state, and now it generates something called as no as a symbol. I meant to say the given string is being not accepted. Is that clear, guys? Is that clear? Any queries regarding this? Okay. Yep. Okay. Meanwhile, let me go with one more example and explain you all. Before that, I'll give you an example. Okay, I want you all to write one more thing. Assume a kid is coming. Okay. Okay. Assume that. Okay. Assume that there is an some encryption in your phone. There is an encryption in your phone, and that okay. I'm not commenting on any movies. A normal way. There is encryption in your phone, and that encryption says if you say hello, the machine will be opened, or the screen will be unlocked, or the screen will be locked. I want everyone to write a machine and a translation table for this. Hello can be said in a way. Hello, hello. I can say in any way. If I say that, the machine has to be accepted and gone to a final state. I want everyone to write this. Meanwhile, I'll be erasing the book. Make it fast, please. Yes, guys. Is that done? hope you're doing on it. Should I want to design for hello only, or should I want to say some more thing? Okay, let me design for hello. How exactly it look like? For example, first and foremost, whenever I get any machine or whenever I get any question, first step is I write a bare minimum string. Okay, my thing says that HELLO. Okay, you want end of it? I feel like it's not necessary for me to do. Okay, just for not to get panic, I write as estimate one, not simple. Okay, now first and the bare minimum say HELLO. The next one is hello, HELLO. And next one HELLO. Clear? And no more C a number of times, E a number of times that ever occur. The only thing which occurs is L and O will get infinite. Okay. Now let me write a diagram of it. Okay. First and foremost, hope you guys remember the symbols which was being used. Single circle says as state. Arrow mark with the symbol says as transition. Single circle with an arrow mark says as start of a state. Double circle represent as final state. Okay, now I'll be making use of this and I'll be writing the diagram. Okay, let me start up a writing of this. Okay, for example, first and foremost, always this is the default thing. I write it as a Q0. Clear? I represent as a Q0. Okay, now as I've been said, you first I have to design a machine for my bare minimal thing. Okay, now Q0, I go to Q1 by getting a symbol called H. Correct? The next, I'll go to Q2 by getting a symbol called he. The next bit is L. I'm in a state called Q3. I'll go to Q3 by taking a symbol L. The next, one more L. Yep. Let me write for a bare minimal string first. Let me write a bare minimal string first. Okay, next is O. I'm sorry, Q5. I will be taking O. The next is not. If I encounter something called a not, I'll be going to Q6, and this will be my last state. I hope everyone have done written a state. Yes. Good work. Okay. Now this is for my bare minimal string, sir. Now what I'll do? Let me get true for second string. H, lovely. I'm going to Q1. E, I'm going to Q2. L, I'm going to Q3. One more L, I'm going to Q4. And 1, 2, 3, 4, 5, 6 L comes. Where I have to go? So at this scenario, what I do? Simple thing. In a state called Q4, I give an infinite symbol and I represent it as an L. Clear? Okay, sir. Hello. For the given string, it work out, sir. What about the next string? HELLO. So HELLO. Remaining O's, what I do? I give an input infinite symbol and I represent as 0. Correct, guys? Perfect. Okay. This can be done like that. There are few students who might ask a question, sir. Don't you feel like you have been wasted one more state? A state called Q3. L. If I use an info, for example, I rewrite the given string in another way. Same way I write it as Q0. I go to Q1 by taking H. I go to Q2 by taking E. And I go to Q3 by taking L. Can't I use infinite in a Q3 only writing as L? Here I go to Q4 and by taking O, I'll write an infinite loop in Q5 and write 0, and I go to Q5, which is the last state, as not. Clear? Don't you feel like I can write the same thing in either way? I've been missed the state. And keep one thing in mind, whenever we design any machine, a design done by a user perception and a user view. Yeah, it can be designed in my own way, my own thing, and there is no standard rule saying like this is a true machine, this is a false machine. There is no standard rules. But always we have to think one thing in mind. Let's write something with respect to an optimistic way. We have to write something with respect to an optimistic way, and then by making use of a bare minimal stage, we have to explain the things and we have to write it. This is how a given thing works. Okay, if you guys have written in this way, you guys are very good. If you're written in this way, you are a double very good. Both are a very good people, not an average or a good people. Is that clear? Whomsoever have written, I say like it's been a tremendous job, guys. Keep up. Okay, should I write a transition? Let me write. I'll write a transition table. Let me recall the things. What and all comes in transition table. Here I write what? Here I write set of symbols. I write as HELLO, ends with a not. And here I write set of states. Okay, now let me write for the same thing. I write it as Q0, Q1, Q2, Q3, Q4, and Q5. Okay, Q0 and H is Q1, Q0 and ELLO is null, 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 and null. Q1 on H illa, null, and this is Q2, null, 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 and null. Okay, Q2 on HE is null, null. Q2 on L is Q3, null, null, and null. Q3 on L is, sorry, null, null, L is Q3. One more L comes, Q3. O comes, Q4, and null. Same thing in. Is that clear, guys? Is that clear? Okay. Now, if you observe the thing transition table which I have been written, don't you feel like I've been used 2L, which is totally a waste? Is that clear? This what we have to keep one thing in mind. Whenever we write any bare minimal string, I'll identify a set of symbols used HELO a set. We have been using only HELO and ends with S. Only 5 things we'll be using, and LLO is not here necessarily. Okay, and I'll write the given thing. Is that clear, guys? Yes. In the next class, we'll go with a practical session of how to write a given finite automata by using a valid string, and I will define what you mean by a finite automata, and I will go ahead with the things. And next class, I'll be explaining the things in detail. Yep. Thank you.